What you're about to see is a series of candid interviews with 4 structural engineers. Each of them has automated a part of their workday that they're just tired of doing. Each of these segments is part of a larger case study interview that I did with each of these engineers. And if you'd like to see the full case studies and to receive your own Engineering Toolkit Automation Roadmap PDF, open up a new browser tab and go to engtoolkit.com. Enjoy the video.
I am Diego Escalante. I am a civil engineer. I come from Ecuador. Now I am finishing my master in Germany at the Technical University of Munich, and I have experience about 2 years here in Germany, as well as 2 years back home in Ecuador. Back there as civil and structural engineer, and here in a consulting office for civil infrastructure projects.
So what kind of projects are you working on right now?
One project in which I am currently involved is like dimensioning the sound fences or sound barriers, Lärmschutzwände called in German, for the sides of the railroad tracks, because it could be really loud, and of course there are a lot of people that can get mad about it. This was the first sketch that I did for my boss and my colleagues to show them, we can somehow make this more easier and understandable for all of us, because we just receive typical Excel sheets that the Deutsche Bahn already has for the projects which we have to give and so on. And as I said, we had a lot of parameters that we had to take into account. You can see here this parameter AG, and that was already fixed to 3.8 meters standard. We had heights ranging from 4 to 6 meters. In this case, we went for the simplified process, to have a first approach to start doing our review models, our drawings, cost estimations, and so on. I did this first approach in which I just used real simple Python functions that I learned through the course.
So just to be clear, we're looking at the Jupyter Lab application, which is what you wrote this in, yeah? And we have a file browser on the left, files in a directory, and then we've got the notebook interface on the right. And what this is like a document that combines executable Python code cells here. You can kind of see them going down the page. And then it allows you to combine those with formatted text or various other media types, like the images we see here. And so this is very similar to a MathCAD sheet, except instead of having to sort of manually lay out all of the math on the page, it's just kind of like a 2-dimensional document. You just write down the page, which makes it so much more easy than, say, something like MathCAD.
Yeah, and also it was really interesting to see that I didn't have the critic or the comments when the colleagues saw it for the first time. Where do I find the length of the wall? Where do I find the height? Since you can combine text and calculations, it's easier to find than when you are using an Excel sheet. It was the first iteration that I did with the simplified method, which is basically just a multiplication of 3 factors referencing the height, the length, and the dynamic influence of the train profile that you have. Dimension your wall or your sound fence for 5 meters before and after the tip of the train, as you can see here.
So you did this prototype for your colleagues to show them basically one iteration of the simplified method, and then you ran them all using this other automated process using your text file, correct?
We took this proof of concept. We just took the information that Down Fence Designer gave us about the distances at the height. We turned that into a TXT file with basically 2 columns. We just ran the script and for each of the cells or each of the rows in our TXT file, do the verification that our HB profile is always under the ratio of 1, and as long as it is under 1, we could use this profile 80%, 90% of the project. We use the same profiles that we somehow estimated with this tool.
Got it. So how much time did this automated process save you on this project?
Well, me personally, at least 1 week work, looking for the values of these dynamic height and length coefficients, and then changing it on every Excel sheet. Of course, there were a lot of places where we had the same distance and the same height. But to do that manually for each of the critical points that we had along the project, it was a really, Germans called ant work.
And so what are the functions that you use here? What did you package up here as a reusable tool?
Well, basically, these are the functions that I created and then that we still use, which was basically taking data that was already ordered in a table. With the help of AI, I told him help me to organize this data into a dictionary. Of course, I had to understand the process behind it and which factor means what. Even the thing that you can do this with a Python function and then you not have to go to the table yourself, type in the value and be prone also to typing errors was a big help.
And now you can reuse these functions for other projects that you have, right? Because you got that source reference table data embedded into that module.
Yeah, I mean, now the next step that we're going to do is since we know that, for example, we have a lot of data for this project that we can organize, for example, at the kilometer 3.75, we have a distance of 3.8 meters, a height of 5 meters, this profile, this thing, x, y, and so on. The next step that we want to implement is just after we have done the design, just create a summary of all the items that we did, because we also have to, give all these documents at the end of the project and to the corresponding offices that take care of the project after this phase of design, to the construction and so on.
I'm Erik Bernhard, 42 years old, from Amsterdam, the Netherlands. I've been doing this work for approximately 20 years now. My bachelor's in Amsterdam, master's degree in Eindhoven. Yeah, I work for a small firm. It's 12 people. Yeah, some firms are even smaller, some are huge. Mainly focused on a lot of renovation in the old city of Amsterdam.
In order for you to sort of speed things along, when did you realize that you needed to start building your own tools?
Yeah, I learned some VBA, so I made some project management stuff for my colleagues faster and simpler, and that sort of propelled oh, this is cool, they really appreciate it. And yeah, but Excel is also limited. Was getting more into programming in general and see what's available, and didn't really know what to expect, if I can build fancy software from ground on or something. But
so before you were building Excel spreadsheets and now you're starting to build tools in Python, how would you describe your approach to building tools now? You're no longer sort of building spreadsheets. Are you building tools for your office? Are you building tools personally? Tell me about what you're building and why you're building it.
Yeah, just mainly for the office, also on the project management side. All the dots are projects we've done in the last 8 years in and around Amsterdam. Yeah, I used was it from Folium also, that they get centered. So as if I zoom in to a certain part, you see all the.
Wow, and you built all this in Python?
Yes. Of course, with the use of ChatGPT, that's really helpful, but you need to do a lot of manual work, of course. We did a project here this is in 2019, this is in 22, and this is the project number. So I just type it in and it's on my screen. I also had to do a lot of scanning a lot of the documents for the project description, because we don't have any description in our project folder list. Yeah, so then now you can see in which area we did all those projects. And I also added.
Oh, that's amazing.
Yeah. Also coloring the red ones. We don't have the CPT files, so the cone penetration test files, and the blue ones we have. So if you're looking for something in that neighborhood. So after this one, I made a different one, because you also have the CPT data, which is actually a .klm file, which actually stores the location. So
man, that is awesome. And so how long did it take you to put this together?
Playing around for a week and during Christmas got more serious and managed to pull it off at some point.
What PDF software do you typically use in your office?
Foxit Reader. Yeah, we don't have a paid version. I know there are fancy PDF software which can do all that stuff.
But that's the point. This is exactly the point, is that when you're a small consultancy, you can't spend on all the fancy software all the time, right? That is overhead, right? And so any kind of tooling you can build in Python, especially for something like that, putting stamps on PDFs, you can do it. That's $400 US a year for
one license,
right?
Yeah. So I have to walk to my colleague's desk. Can I please use program this and that to check these files? Yeah.
It's possible to build these tools with open source libraries in Python And these, like, just even these really small things, right? Like, can just save you time and money.
Yeah, for me, mostly it just makes my life a bit easier. And
The amount of time that you spend doing that desk work, right? That, like, all that work you're able to get now almost like an instant. You just, like, you look for the address, boom, what do we see? What do we have for CPT files? You know, what's the data there? You can sort of piece together a story quickly. Like, how much time does that save you?
so when I have to review projects from a colleague who just started, I look at the stuff and think, let me look on the project map if we have something around and quickly check there how it went there. It saves a lot of time. Yeah.
My name is Gustavo Alonso. I live in Chile. I have over 8 years of experience as a structural engineer. 2 years ago, I started practicing as a structural engineer focused mainly on mass timber structures, working for a forestry company called Arauco.
You've taken this Python course with me, and you've started building tools now using Python. How would you describe the difference between what you're doing before and what you're doing now?
Well, it's completely different because now what you're doing, what allows you Python to do is actually to build blocks, small blocks that are calibrated. Whenever I use a function, I use a unit test. It gives you the possibility to be certain that all these blocks that is the foundation of your program, let's say, they're good. So that's something that really changed my perspective. Here are my libraries that I use. The pandas, the NumPy, and your libraries for people in hand calcs. I have to say they're super useful, extremely useful.
So I noticed that in your code there, you've got import mass timber GD as MT. Can you tell me about that? This is something that you've written, and is because it's importable, it's reusable, right?
Right. What we're seeing here are when I build this formula and where I test them, I calibrate them, let's say. But then I had to copy them in this Python document where I have only the formulas.
Got it. You've formalized it in here. You've developed it in the Jupyter notebook, and you worked out to make it work, and then you copied it over into a Python module, which is just a text file. Now that you have it in this .py file, you are able to just import this whole toolkit into whatever job you're working on.
What I do is that I import all this library, and of course I input my library as well. This one, MathTimber GD, those are my initials, as MT. And therefore, if I want to use a certain formula, I only need to put MT and then all the other formulas, MT and all these formula.
So the nice thing about this is that you may not be like necessarily following the same process for every job, but each job will almost always have the same or similar components that you need from your MathTimber toolkit, right?
Right, because I have a file for the verification of slab. They have this glulam beam, they have the slab CLT, they have the wall of CLT, and all the rest. Let me show you. You need certain formulas for the verification of a wall, or for a slab, or for a connection, or for a beam, or even for plywood. I even have one for steel, ST, a beam made out of steel.
I'm curious about the Excel versus Python part, right? Because in a lot of ways, it's kind of like, well, if you've got a spreadsheet that's all set up to do what you need, you're just putting inputs in and you're getting a result. Similar with Python, you're putting inputs in and you're getting a result. Where you were spending your time, like what was it about Excel that was not fulfilling what you needed?
The most difference is in developing the tool. Definitely the certainty that gives you Python, because you are developing block by block, you're certain that it's calibrated, and so you're certain that the units are correct, because that's not a warranty that gives you Excel. Therefore, you have to check at the end of the work.
When you have an Excel sheet, it's kind of like it's frozen. Like you got a whole process that's frozen in one place. And as you showed, right, with all of your tables on one sheet, that if you needed to make those modifications, the pain required, to make those modifications is high. I mean, how long would it take you to put a new notebook together using your tools? You tell me.
A completely new notebook could be half a day, but but it's different because, as you said, in Python you had to develop only the steps, but the blocks you're sure they're going to work because you have them calibrated. But in Excel, you have to develop the methodology, and you have to check if every one of those blocks, let's say, are working correctly.
My name is Mohammed. People call me Mo. I am a structure engineer and I work in Cardiff here in the United Kingdom. I've been working for almost 4 years now. I've started off doing a bit of civils, but then moved to structures.
You told me that you built a tool in Tekla Structural Designer. Can you talk about that?
Yeah. So basically, I wanted to create a tool that I'm still developing, but the tool basically reads and analyzes the Tekla Structure Designer export. So Tekla Structure Designer allows you to export an Excel sheet, which has your ports and then the coordinates and all the forces. All of that is in one Excel sheet. And my tool basically reads that Excel sheet and then it puts everything in a data frame. Basically, you get this screen as you start the app and have the ability to upload basically Excel sheets or Excel documents using this upload window here. I've added this bit in my code just in case someone just wants to try it and doesn't have a Tekla Structure Designer Excel sheet in hand. So I just did this so that if anyone wants to.
Perfect.
Some instructions here, and so that's the code. That's the web app. So
all right. So what are we looking at here?
Right. So you've got a plot of the supports locations, basically the support name as in Tekla, and then I've got this bit here in which I've got a drop down which has a number of options, so you can find the number. Let's say I'm interested in getting the maximum FX forces or the maximum FY FZ. All I do is just click on that and then generate. It will generate this sort of bar chart. Just give me, this basically gives me the sort of extremes. Let's say I just want to look at the extremes. Oh, okay. So it's like
max and min,
exactly.
over envelope over all your load cases.
Exactly. And it's minus 80. I know.
And how many load cases are you running?
I think in this one I've got 100 something load cases. But I mean, Python is quite quick. I've done this in which you can basically just quickly hover on top of the support, and then you get the support name in Tekla. So here support #2 #5, and then you get the maximum plus FX force, and then you get the maximum minus FX force, and then you get the combination that relates to the maximum FX force.
So what are the biggest piles? Let's see some big pile actions here.
So let's do number of piles, and let's just use the default. I just use the default axial and tensile capacity, and I've just got a note there saying walls are beyond scope for now. Right, so this is how it looks like, and it's easy to just look at it and see, I've got 3 piles, and is that one there? That's and again, that's not something I can do quickly on Tekla.
When you had to do this previously, you were doing it sort of manually without your tool here.
Exactly.
How long did it take you to do, say, this example file?
I remember doing something similar it was a bigger job, and I think it took about 2 days, sorry.
Woof.
Got all these.
And you're going cross-eyed, and then you're like, did I screw it up?
Right. Yeah.
I know.
And then you are already halfway through the process. You're like, no, that doesn't work. I need to redo it again because it just doesn't work.
Like it's beautiful that way, right? Like in this, and the amount of busy work, like time you spent in busy work compiling that information, as you said, was like 2 days.
Yeah.
And now you're doing it in 5 minutes?
Yeah, exactly. Yeah.
And this is just like, and this is the first thing you've built, right? This is the first tool you built.
Yeah.
After the course.
That's right. Yeah.
And how long did it take you to build this tool?
Maybe 4 hours a week. Maybe I wasn't really, whenever I've got time, sometimes, I don't work on it for 3 days and then come back and work on it on the weekend.
That sounds about right. 4 hours a week sort of thing. And, so 3 or 4 weeks, so like 12 hours-ish. Yeah. And this is the first one you built.
Yeah.
I reviewed your code for this one, right? And the way you've written it is such that like it's definitely reusable, and you'll be able to build on it, take, use parts of it for other stuff. And it's great. I think you did a wonderful job on this. And so have you presented this to your team yet?
Yes, I did share a few of my colleagues. They did really like it. I do want to still continue working on it. I just want to make it a little
course.
bit more nicer, and then yeah, definitely share it with the wider team.
Nice. Were they like, Mo, can I use your tool to do this?
Yeah. I want to be able to use this tool as well because what we do is we provide pile loadings to piling subcontractors. I want to be able to extract the data from Tekla and have my code sort of arrange everything, put it nicely in a nice Excel sheet with our company logo at the top, and then it's just ready to go.